Hi guys, welcome to today's class. Today we are going to continue the topic of differentiation, and we are going to be looking at the equation of tangents and normals to a curve. So the first thing that we need to know is that the gradient of a curve is the same as the gradient of a tangent to the curve at that point. So basically, this is what you need to know. The gradient of the curve is the same as the gradient of the tangent to the curve at that point. So now let us go to example 1. Question is, find the equation of the tangent to the curve you've been given y is equals to x cubed plus 2x plus 1 at 1, 4. So this is what you've been given. You've been asked to find the equation of the tangent to the curve for y is equals to x cubed plus 2x plus 1 at point 1, 4, and this is xy. So what you do, you come here and you differentiate it first. So dy over dx will be, like I said, you drop 3 down, x, 3 minus 1 is 2, plus, here it's 1, so 1 times 2, 2, 1 minus 1, 0, so x becomes 1, so it's 2, plus 1, we don't count it. So when you first find the derivative, you remember we've been given at point 1, 4. So for you to find the gradient, you come and take your first derivative. So 3 on x, this is x, you replace it with 1 squared plus 2. So this becomes 3 plus 2, which is equals to 5. So the gradient of the tangent is 5. So this is how you find the gradient. First you find the derivative, and by this dy over dx, you bring 3 down, x, 3 minus 1, 2, plus 2x, 1 minus 1 is 0, x raised to 0 is 1. And we don't touch this term because it doesn't have an x. So this becomes 3x squared plus 2. So where there is x, you replace with 1 at point x is 1. So it becomes 3, 1 squared plus 2. 1 squared is 1, 3 times 1 is 3, plus 2, 5. So your gradient is 5. And remember, so our gradient is 5. Having the gradient to be 5, and the point is 1, 4, xy, and you've been asked to find the equation. So like how we were doing in gradient book 2, so for the gradient is equals to y2 minus y1 over x2 minus x1. So we can set another point to be xy. So this becomes y2, x2, y1, x1. So this becomes y2, y minus 4 over x minus 1. The gradient was 5. So we cross multiply both sides by x minus 1 by x minus 1. So this becomes 5x minus 5 is equals to y minus 4. So basically we bring this 4 to this side, it becomes 5x minus 5 plus 4 is equals to y. So this becomes 5x minus 5 plus 4 minus 1 is equals to y. So the equation of the tangent is 5x minus 1 is equals to y. So this is basically how we do. So what we just changed here, in finding the gradient, here we are using the first derivative. And after finding the first derivative, you replace the value of x with what you've been given. Let us look at another example. You've been asked to find the equation of the normal to the curve. Find the equation of the normal to the curve. And here you've been given y is equals to x cubed minus 2x minus 1 at 1 minus 2. So basically what you do here, so when you get here, first thing we said you find the gradient, and when finding the gradient you first find the first derivative. So dy over dx, and this is bring 3 down, x, 3 minus 1, 2, minus 1, so it becomes 2. 1 minus 1 is 0, so it becomes 0. And here we don't have any x, so we leave it at that. So our first derivative gives us 3x squared minus 2. And our x is 1. So you come here and replace 3, 1 squared minus 2. So this becomes 3 minus 2 is equals to 1. So the gradient is 1. And remember, this is the gradient of the curve is 1. And when it comes to the normal, what you normally do, the gradient of the tangent is perpendicular to the gradient of the normal. And remember, in perpendicular lines, we said gradient 1 times gradient 2 should give us negative 1. And since we are finding for the normal, and we know the line for the normal is the curve for the normal is perpendicular to that for the tangents. So what you do, this is for the tangent is 1 times x, which we don't know for the normal, is equals to negative 1. So x automatically becomes negative 1 because 1 divided by 1 is negative 1. So we know our gradient for the normal is negative 1. So once you have the gradient, you come back here. We know the gradient is negative 1. And we have the point 1 minus 2. You can assume another point, xy. So gradient is equals to y2 minus y1 over x2 minus x1. So this becomes y minus 2 over x minus 1 is equals to negative 1. Again, multiply both sides by x minus 1 by x minus 1. So this and this will cancel. You are left with minus 1 times x, negative x. Minus 1 times negative 1 plus 1 is equals to y, negative plus negative and negative gives us plus 2. So you can bring this 2 to this side, negative x plus 1 minus 2 is equals to y. So this becomes negative x, 1 minus 2 minus 1 is equals to y. So the equation of the normal to the curve is y is equals to negative x minus 1. So this is how we do. So today we've only looked at these two examples. We've seen the equation of the tangent to the curve, and we've seen the equation of the normal. And the difference is, for the normal, you remember they are perpendicular. So once you get the gradient, you have to divide it by negative 1 in order to get the gradient for the normal curve. So basically that is what we've learned today. So you can practice, and if you're in Form 4, you can look for book 4 under this topic of differentiation, under equation of tangents and normals to a curve. And with what I've explained here, I hope you've understood. You can actually use it and try doing the examples on your book. So those are the two different examples that I wanted to teach us today. I hope you understand them. In case of any question, guys, you can just write on the comments, and yeah, you can share with your friends. Thank you.